I'll give everybody about 60 seconds to get seated and we'll start this. Appreciate everybody joining us today. Is the sun still trying to peek out? A little bit? Can we all kind of just have that vibe in our head real quick to let the sun come out, right? All right. Appreciate everyone joining us. This is a very exciting event for me to MC the Fireside Chat here at UTD. My name is Dan Brunoff. I'm a meteorologist for KRLD Radio here in the Dallas-Fort Worth area. It's 1080 AM on the radio dial. A lot of you may not know what AM radio is, but I kind of grew up with it with my parents. And you know, I was actually born and raised here in North Dallas, a little town called Farmers Branch. And I went to W.T. White High School before the Galleria was even built. And I stayed here up until 1996 at the ripe old age of 30. I followed my childhood dream. I saw my first tornado in 1977 that came through North Dallas and saw it out the back window of my parents' station wagon. And I told my parents that I wanted a weather radio. And so they bought me one from an electronics store. Some of you people that are my age remember Radio Shack. And so I still have that weather radio today. It's pretty interesting. And it still works. It takes a 9-volt battery. And I carried that guy with me everywhere on camping trips. I took it to sleepovers. I took it to school, to high school, and got it taken away from me at least 3 or 4 times for pushing the button in class and trying to see where the cold front was. I was a weather geek, and I still am. And I waited until I was we'll say 27 to start college. I had a long stint in the restaurant business here in Dallas and Fort Worth. And I just woke up one morning. I had moved to Fort Worth to open a couple of restaurants for a good friend of mine. And my head cleared, and I was like, you know, I'm going to go to college. And so I got accepted to Texas A&M in 1996. And I started their their Bachelor of Science degree program in meteorology. And I graduated in 1999 at the ripe old age of 33. And I'm celebrating my 26th year of doing television and radio weather across mainly the southern tier of the United States. And I remember telling my parents back when I was about 8 or 9 years old that I wanted to do weather in Dallas and Fort Worth. And the irony about seeing a tornado in 1977 was that when I told them that, 42 years later, October 20th, 2019, how many remember the tornado that ripped through North Dallas on a Sunday evening when the Cowboys game was on? All right. That tornado took the almost identical path as the one I saw as a little kid back in the 70s. The one in 2019 was a lot longer. It was on the ground for 32 minutes. It was rated as an EF3 with peak wind gusts of 140 miles per hour as it roared through the North Dallas area between Royal Lane and Walnut Hill before crossing over Central Expressway and ripping up that Home Depot there at Forest and Central Expressway. And then it missed this area by about 3 miles to the east and hit East Richardson, West Garland before dissipating. So I wish my parents were alive to hear me cover that, but I was on the air for 6 hours straight, and I didn't sleep for 36 hours. As soon as that tornado hit the ground, adrenaline, and it hit some of my old friends' parents' house in the old neighborhood I grew up with. And so I helped the next morning with cleanup. Finally exhausted, I came home and rested. So this is peak severe weather season, but it's also we're here for the Eclipse. So that's a little bit about myself. I love what I do, and I appreciate everybody here joining me here for the Fireside Chat. All right, we got some really, really nice guests today. We have Dr. Ishak Bushaki, and we also have Dr. Eileen Stansberry from NASA. So there's me. I waited till the last minute to show me. 13th year at KRLD. We're going to talk about Dr. Eileen Stansberry. A wonderful, knowledgeable woman that you guys, this is a treat for her to make her trek up here to talk to us. Let me tell you a little bit about Dr. Stansberry. Chief scientist at NASA at the Johnson Space Center. Huge job. As well as chief of the Astromaterials Research and Exploration Science. a division where she's responsible for directing a multidisciplinary scientific organization of about 250 civil servants and contractors to support NASA's planetary science, human exploration, and space science enterprises. The organization's primary functions include stewardship of all of NASA's handheld extraterrestrial samples. Those are rocks from outer space. Really cool. Also, she provides scientific advice and assessments to center and agencies' leadership directed towards the development of world-class scientific research, as well as human and robotic mission capabilities for exploration, primarily the Moon, Mars, and planetary small bodies. She previously served as the Deputy Director of Exploration, Integration, and Science. Eileen earned her doctorate in space physics from Rice University and her Bachelor of Science in Mathematics and Physics from Houston Baptist University, in addition to many internal NASA honors, including Outstanding Leadership, Exceptional Service, also Equal Employment Opportunity Medals. Eileen was honored with the 2013 AAS Carl Sagan Memorial Award. So on behalf of Dr. Stansberry and myself and UTD, we do welcome Dr. Eileen Stansberry.
I think I'm a little shorter than Dan. It's my honor to be here today to represent NASA on behalf of the Space Center. I do want to welcome y'all to this fabulous event. It's not often that you get a total solar eclipse, but a little bit about the organization that I serve. My job as the chief scientist of the Johnson Space Center is primarily advisory and providing insight and oversight to what is primarily a human spaceflight center. So especially in preparation for the Artemis missions, going back to the moon, a lot of work in planning for what we do when we get there and why we want to go back to the moon to begin with comes out of my organization. If you're science but not biology, you basically report to me at the Johnson Space Center. So we put the science into the mission planning for future missions. It's really important to not just go places, but actually do something. And our heritage is started with the Apollo program, and we provide for the safekeeping of all of the NASA-held extraterrestrial materials. So you can think of us as the Marines of rocks. We protect, preserve, document, and distribute. Make them available to the worldwide scientific community. We also have a cadre of scientists that study these samples and provide insight into how to best handle the samples so that the external scientific community can make the best use of those samples. Those scientists also are part of exploring planetary worlds. You may think of the Goddard Space Flight Center and the Jet Propulsion Laboratory as the two NASA centers that lead in planetary exploration, and that is correct. But we have a niche expertise within my organization of analytic interpretation. So because we're experts in planetary materials, we can provide that expertise for interpreting the measurements that come back from other planetary bodies. And we provide cross-calibration from various missions in those planetary materials. That also means that we can provide science operations support. So we actually do some uplink and downlink commanding to the Mars rovers from the Johnson Space Center. And we also provide scientists who help plan and prioritize which measurements get made. This same level of scientific expertise is also used to keep spaceflight safe. The type of analytical questioning that we provide to planetary missions, we also use for managing the nation's and leading the nation's orbital debris program, making sure that you understand the impact of impacts, the damage that can occur from both natural and man-made objects in orbit. We also provide for the surveys of spacecraft prior to leaving the International Space Station and coming home to make sure that if something hits one of these spacecraft, that we know that it's still safe to enter Earth's atmosphere. We do prepare for future human explorations by providing training for astronauts and other explorers to both prepare for humans on another world, as well as interpretation of observations from the International Space Station. My organization actually looks like this. We're 4 different branches of the division that concentrate on the safe planning and keeping of extraterrestrial materials, the analysis of those materials, planetary robotics missions, as well as making our unique analytical instrumentation available to the wide scientific community. In exploration science, this is a big part of our organization for planning the Artemis missions programs. And for hypervelocity impact and orbital debris, it is working with other nations and other government agencies to understand the environment as well as the risk to both to both human missions and robotic missions and commercial missions now. But we've also recently been given the charge to develop a project for Mars sample return. So we actually will be the 4th project in the Mars sample return campaign. So once the samples come back to Earth, as soon as they touch ground in the landing location, then we have the responsibility for taking over in making sure that those samples are recovered and properly cared for and made available for the scientific community, while making sure that we also keep the Earth's ecosystem uncontaminated. So it's a large scope of work that we do, but it's very exciting, and every day is an interesting and different day.
Thank you very much. Very interesting, all the work that you do, and we appreciate everything that you do in your career and for being here today as well. So thank you very much. All right, our next special guest is Dr. Mustafa Ishaq Boushaki, and some of you may know him here from UTD. He is a professor, and let me tell you a little bit about his background and his history in this science field and the industry that we're all pretty much interested in. All right, Dr. Mustafa Boushaki is a professor of physics and astrophysics here at the UTD. He completed his PhD degree with distinction in 2002 at Queen's University in Canada in general relativity and cosmology, and received the prestigious fellowship of Research Council of Canada. After that, he joined Princeton University as a research associate in the fields of modern cosmology and astrophysics. In 2005, he joined UTD right here in UTD Dallas and built an active research group in astrophysics and cosmology, contributing to research, teaching, and outreach activities. Professor Ishak's scientific work has been disseminated in over 100 publications and with over 6,000 citations. His research work includes the study of the expansion of the universe, the problem of cosmic acceleration, and the theory of gravity of Einstein. Professor Ishak has been honored as fellow of the American Association of Advancement of Sciences, otherwise known as AAAS, and a fellow of American Physical Society. He's also a recipient of the Outstanding Teaching Award from the NSM School right here at UTD, and also at UTD's President Teaching Excellence Award as well. The UT Systems Regents Outstanding Teacher Award, and also UT Dallas Provost's Award for Excellence in Graduate Research Monitoring. Please put your hands together for Dr. Ishak, and again, here is Dr. Bushaki.
Thank you very much for the kind introduction. Hello, UTD. Hello, everyone. I am very delighted to be here today in this fireside chat talk, and also for all this wonderful event on campus of at UT Dallas. I'm here particularly today to tell you a story will take you with me into this journey, into this story about the eclipse that changed the world. If you Google it, you will find it exactly with these terms. So I'm a teacher, so I like to wander on the stage when I talk. So let's see. Before I do that, I wanted to tell you a few words about our group here at UT Dallas. What we do, very briefly, we study the structure and the evolution of the universe as a whole. So the universe has a model, and it evolves and it expands. So we study the expansion of the universe, we study its component, and so forth. We use in our work, we use some physics, mathematics, computers, and also the data collected from surveys and telescopes. In fact, I couldn't help it to tell you that incidentally last week we made a really very big discovery in the field of cosmic acceleration. It coincides with this one. And so I wanted to just briefly to tell you about it. It was echoed all over the world, and so I couldn't resist to share that with you, but that's a story for another day, not today. Okay, so here we go. Back to the eclipse that changed the world. There are many eclipses, historical eclipses, but I will tell you about this one. This one happened on May 29th, 1919. It confirmed the theory of Einstein. This eclipse helped scientists to confirm the theory of Einstein. And that is the accurate theory of gravity that must be used. In fact, ask your GPS, and it will tell you about that. How come? If you, in your GPS, general relativity of Einstein as a gravitation theory has been programmed, has been coded. And if we don't do that, the GPS will be off by 10 kilometers every day, 10 miles, 15 kilometers every day. Can you imagine after 1 week what's going to happen with your GPS? So general relativity is really in everyday's life. Satellites, GPSs, they use it, they have it inside. And here we go. So let's talk how this eclipse confirmed general relativity. Let's start here. So let's say UTD is here on Earth, right there. And then we are observing stars. When the sun is not there, not in this position, you look, there is this star. So if you look here from UTD and you see this star in a straight line, you will see this position of the star. Great. This is the real location of the star, if the sun was not there. But then, because the Earth is gravitating around the sun, it comes that at some time then the sun is in between, is in the way. When the sun is in the way, what happens is that the starlight coming from the star is going in this direction. But instead of going this way, continuing this way, it gets bent. It gets bent here, deflected by the sun. It gets deflected and it comes to us here at UTD, and then we look. And then when we look, what we see a ray of light coming this way to us. So the impression that it creates is that we are seeing the star straight forward. So we are seeing the star being at this position. So this is the real position. This is the apparent position. So they move. They move by an angle here. And that angle is key. That angle is the key. In Newton theory, this angle should be 0.875 arcsecond. In Einstein theory, it should be twice as much. So it became why twice as much? Because the theory of gravity of Einstein, it's about the fact that the universe, the space-time is curved by the sun, by objects. It's a very, it's a challenging idea. So when Einstein came up with this idea, the people said, wait a minute, I mean, this is, even the scientists said, okay, it's a nice idea, but how can we prove it? And that's how it was proven. At that time, they didn't have any GPS. So it was then became between, and again, in Einstein relativity, why it's twice as much? One is because of the bending of light, and the other one is because of the contraction of space. So the angle gets bigger. All right, then, at that time, it was a very big competition, very big ideas between Einstein, Albert Einstein, versus Newton's gravity that was established for 300 years at least. So let's see what happened now. Here we go. I was on a plane. I was on a plane and on Saturday, and I did a little cartoon here. So if you look at the stars here, you see the stars. This is when the sun is not there. You look at this stars. You see their position here, and then once the sun gets in the way, this is what you observe. And I don't know if you can notice, but look at the stars. They move a little bit away from the sun. So here, back, forth, back, forth. So the stars, they move a little bit away because of that bending angle. And then becomes the mission is to try to measure this angle. But now, what has it to do with the eclipse? If you go with the sun between us and you try to measure this position, you won't be able to, because the sun is too bright and you cannot see them. And here came a bright thinking, a bright plan to use the eclipse that will cover completely this sun, and then you can see the bright, nice stars here, and you can measure them. And that's the idea that came up with, his name is Arthur Eddington. He came with this idea of using an eclipse that was going to happen in 1919. It was going to be the path of totality, was going from South America here in Sobral in Brazil, go all over the Atlantic, and then also in Central Africa, the island of Principe. he designed, actually Arthur Eddington is my academic grandfather. So there are three advisors in between. And so he thought about it. He said, how about if there will be bad weather in one of the two locations? So he said, you know, we will do 2 expeditions. And that was a very good idea that they did 2 expeditions. They sent one to Isle of Principe, and they sent one to Sobral in Brazil. And in fact, it was a great idea because guess what? The one in Island of Principe did not work. It was very, very cloudy. And here you go, if you can see this plot, I won't show you much, the results. The results comes all along the Einstein theory here, and not the one of Newton. That was the moment. That was the moment of Einstein. And they measured that indeed he was the 1.75 arc seconds in agreement with Einstein and not Newton. And that was the turning point for Albert Einstein. He was everywhere. He even had the UTD sunglasses. And then I wanted to tell you again what has it to do with UT Dallas as well, this experiment, this memorable event. 100 years later, all the international community of astronomy, they decided to do a huge event, international, in Europe, in America, South America, in Africa, Asia, Australia, all coordinated at one time, 100 years later. And they did it. And in fact, what it has to do with UT Dallas is that we have been asked to deliver the inaugural talk for the opening talk for that huge, nice ceremony. And in fact, I will tell you about this. When I went to Brazil, to Sobral, and they kept all the material there, they kept all what they built, they made a museum out of it. And believe me, it felt like a real travel in space and in time as well. So that is thanks to the Eclipse, and thanks to your attention.
Thank you so much, Dr. Bouchaki. Interesting, right? Just incredible stuff. Did I get a young yeah somewhere? Where was that? I love it. Young scientists in the building. All right, I was young at one time. Okay, so let's move on, and we're going to have a little fireside chat. The only thing we're missing is a little fire pit, right? So just imagine there's a little fire here, and there's some crickets going, which we might hear when we go totality here at a little after, right around 1:40 or so. You know, the crickets come out. Sometimes the planets are visible. And I just looked at the visible satellite. That satellite imagery can only be seen when the sun's out, right? Or maybe you didn't know, but now you know. That clouds are starting to break up a little bit. There's still some high clouds out there, so fingers crossed, okay? We have to wait 300 plus years for this to happen. I don't think any of us will be here in Dallas and Fort Worth. That'll happen other places around the globe, but just not right here. So this is a very, very special day. So again, keep those positive vibes going. All right, so I'm going to sit down with the crew here and our guests, and I'm going to ask them a series of questions, and hopefully you'll learn something. I know I will as well. Okay, first question is for both of you. And I know we kind of touched on this just a little bit ago at the beginning with the eclipse with Dr. Bouchaki. But the first question is for both of you, and we'll start with Dr. Stansberry here. And the first one is, what causes the solar eclipse, and why is it such a big deal when one is coming here?
Okay, solar eclipse is when the Earth passes through the shadow of the moon, And even though the sun is about 400 times larger than the moon, it's also almost exactly 400 times further away. So under the right conditions, the two can appear approximately the same size in the sky. Now, the orbits of the moon around the Earth and the Earth around the sun are slightly elliptical. So sometimes the moon and or the sun is a little closer, sometimes a little farther away. And unless everything is just in the right place, so you've heard the being at the right place at the right time, well, that's what solar eclipses are, is if the moon is a little bit further away than average during an eclipse, it won't be quite big enough to be able to obscure the entirety of the sun, and that's when you see an annular eclipse, a ring eclipse, and the most recent one of those was in October of this last year. But basically, these eclipses require the sun and the moon and the earth to all be aligned at just the right spot.
Yeah, interesting. I remember the one last October. And, you know, the trees, you can actually see the little pinhole. It's called a little pinhole that the tree leaves cause, and you can actually see little crescents all on the ground, as long as it happens, of course, in the spring, you know, or when we have foliage on our trees. But Dr. Bishaki, why? Let's put it this: why eclipses are rare in particular places? I mean, are they confined just to certain areas? How do they move around the globe, the shadow, and why viewing an eclipse is so exciting for the general public, like all of us today?
Sure. So to know why the eclipses are rare is because we look at the orbit of the Earth around the sun, and then we look also at the orbit of the moon around the Earth. They have two paths. And then if we can go back just to that.
Want to go back?
Yeah. So when we look at those two ellipses or two orbits, they are tilted with each other about 5 degrees. So they don't coincide. Only at 2 points, they call them the nodes, so they coincide. So to get an ellipse, you need them to coincide, that one. You need also to have the full moon, so you have a phase of the moon. That's 2. You need also to have to be at the right place, to have the umbra, to be in the umbra to see a total eclipse. And in fact, it's interesting. So the umbra is the kind of technical word for the path of totality. When I heard the first one about this one, it scared me. The path of totality. But that's the umbra. So if we are under the umbra, we see the full, the total eclipse. But then if we are in the penumbra, a little bit to the side, we see just a partial eclipse. And one other thing I want to say, why you said why rare, is because of this. Because also the path of of totality, it only 1% of less than 1% of the surface of the Earth. And again, the Earth is like kind of 70% of water. So all that combined, it takes about 300-400 years to get it at the same place.
Wow.
Yeah.
So we won't be here for the next one, right here where we're sitting, right? So this is a special day, and again, we're watching those clouds right now. So these are just a couple of graphics, so we can get this to fast forward. Sometimes it's been a little bit slow here. Here we go. So basically, we went through this. These are some of the times that we were showing earlier that we have up here and everything pretty much in our area. These are some of the last ones that we had next total eclipses. You can kind of see some of them are even unknown. I guess the figures aren't there to be able to determine. And these different towns, mainly the bigger towns, Dallas, Fort Worth, maybe up towards Paris, and Hearn is down by College Station. So kind of give you an idea. These things are rare, folks. And some of the things that are very interesting here, it'll probably be easier for me to look at this over here. But again, some of the things that happen during totality is, of course, a lot of the animals go into shelter. I'd love to be at a zoo for 4 minutes just to see all the go back in their little dens and, you know, take a little nap for 4 minutes. They're not going to know what's going on. Maybe a Walmart parking lot when, you know, when the birds come in at sunset and they're all in those oak trees making those noises. I wonder if they'll flock there for 4 minutes and then leave. It'd be kind of an interesting. So things happen with the wildlife. It's very interesting, to say the least. Okay, so we'll move on to the next one, eye safety. Of course, everybody got their eyeglasses, okay? Please wear those. But remember, when it goes total for about a little over 3 minutes right here where we're sitting, you can take your glasses off, right?
Yeah, basically the fundamental thing that you think about in terms of eye safety is you never want to stare directly at the sun. And that's true whether you have an eclipse or not, because your eyeball is not designed to handle the intense rays. The reason why people stress eye safety for an eclipse is during an eclipse, people are just more likely to want to stare at the sun because it's an interesting event. It's different, but it's the same as staring at the sun at noon on any day. That's not a good idea. But in particular, if you are using a lens, whether it is a camera or binoculars or a telescope, any lens, if it doesn't have a proper filter on it, it will focus and concentrate the rays of the sun and provide damage to your eye much, much quicker because you've got a higher intensity of the sun's rays. You're not at any more of a risk with animals or babies looking at the sun than any other day. But once you get to an age where a child understands that this is something different going on, you need to be very, very careful because it's, staring at the sun absolutely can cause blindness. And using an appropriate, proper filter, whether it is a filter on your camera, a filter on your binoculars or telescope, or the specially designed glasses to block out those harmful rays, is much, much different filtering than you would have on even the darkest sunglasses. So regular sunglasses, absolutely not appropriate for filtering out. Right.
I know, Dr. Bushaki, you talked a lot about this on the introduction after I introduced you, but just in summary, what are some of the things we have learned from the eclipses about gravitation and the universe beyond our planet and the solar system? How do we learn from each of these total eclipses around the planet?
Sure. I think what we learned from the eclipse is that the exact theory of gravity is that of Einstein. And but then, who knows, maybe there are little Einsteins that will use the eclipse and think about other tests to test other things, to validate other things. There's dark matter, there is dark energy, there is a lot of mysteries there in the universe. So who knows? Think about the eclipse. Maybe it's going to give you some ideas.
Mm-hmm. Well, Dr. Stansberry, back in the day, okay, imagine without the science, without the cell phones, without the internet, without being able to spread the word. I mean, it took forever just on horseback to get a letter, right? And then before that, it was a telegraph, right? Just to be able to inform people and be educated enough about a certain subject to be able to inform people. Don't worry, it's okay, it's just the moon, right? Passing in front of the sun, and we're okay. It'll last a few minutes, and we can go about our day. So what do you think they were thinking back then? I mean, just, I could only imagine how scared people were, and they didn't know what was going on.
Absolutely true. Today, scientists use solar eclipses to study the sun's outer atmosphere and corona, and we can understand a variety of things about the formation and evolution of our solar system. But back in history, there have been a number of cultures that view solar eclipses as a bad omen. That whether it is the Chinese culture of the dragon eating the sun, or the Mayan and Inca cultures having a divine intervention. This has been true throughout a wide variety of civilizations. One sort of interesting fact or story that I like to tell on the impact of an eclipse is from 585 BC. It's the story of Thales. Thales is a Greek philosopher who actually predicted a solar eclipse. This was a prediction that was going to coincide with two kingdoms of the time, Medes and Lydia, who had been at war for quite a number of years. And when the eclipse happened, both armies took it as a bad omen, and both armies laid down their arms and surrendered.
Wow.
Yeah, it's one of those things where the visceral reaction to these kinds of events can be very profound, and because both armies were reacted in similar ways, the terms of peace, because it did result in peace between these two nations, was the marriage of the daughter of the king of Lydia to the son of the king of Medes. And sort of in history, a lot of cementing of peace has always been about, okay, let's merge the families. And that's exactly what happened. But in addition, because that's one of the early examples of a prediction of an eclipse, this was mentioned in the historical record by Herodotus, who wrote about this foretelling, and Aristotle basically called Thales the first person to fathom nature.
Interesting. So, and we're worried about running out of gas, and that's the things. It's amazing the contrast of people, way back when, before the science was really starting to evolve, to where we are today. I mean, we kind of know why it's happening, and there's still those conspiracy theories or things even today that are going around. Now, they're a lot different than they were back then, but it's interesting that we still, everybody has their own opinion on things. So. This question to Dr. Ishak, I'm going to step forward a little bit because of time. I'm going to go down to number 7 question. I'm going to share a personal experience or anecdote related to a solar eclipse that had some impact on your scientific journey or perspective.
Sure. Well, there are 2 stories that had an impact on my career or my life. So the first one is this story about the eclipse that I told you about. I heard about it when I was like maybe 6 or 7 years old, and it's kind of stuck in my mind. Now I understand it. But the other story is actually an anecdote. I don't know how many in the room here are fan of Tintin. By Hergé, yes. So Tintin actually, the prisoners of the sun. So I remember I was, again, same age, maybe 8 years old, maybe 9 or something. So I read the Prisoners of the Sun, and then where he's held, roped and held hostage in the Incas or the Mayas. And then he remembered there is an eclipse. And while being there to be, punished by him and his friends, he came up with this idea to start talking to the sun and kind of commanding the sun to go away and things like that, to hide the sun. So he made that discussion, and then, yes, it happened, the eclipse happened, and he kind of has an effect. And so I think that kind of resonated with my sense of, I like also adventure. However, I must say that this is a very nice story, yes, very cool, but Hergé, who wrote this, actually realized afterwards that the Mayans or the Incas that he represented in that, actually they already knew about the eclipses, and he kind of was sorry that he overlooked this fact. But anyway, taking it like, I really like the kind of adventurous way and creative sense of that. So those are the two memories I have.
Okay, yeah, the Mayans really stood out, didn't they? I mean, for ancient cultures, I mean, they were probably the most intelligent, right?
Oh, yes.
Pretty much, yeah. So, I mean, there's a lot of course, in Central America, right? That's where most of them resided. So you can go, if you ever go on like a cruise, they have some of those little excursions you can take, and you can kind of get a glimpse of what things were like and how intelligent they really, really are. Let's go to... and this is a question for both of you. We can start with Dr. Stansbury. Any personal experience, again, an anecdote, and I'm going to have this question related to you as well, that had some impact on your scientific journey or perspective?
Rather than scientific journey, I will say something that is relevant to today. My first eclipse that I saw was in 2012. Went down to Australia to see the total eclipse in 2012. I had previously photographed the sun, so I have set a camera set with the appropriate filters to photograph the sun and photograph sunspots and things like that. Which is a lot of fun and really interesting. And so I wanted to use that capability to photograph the sun, look at the corona and the Bailey's beads and the wisps that you can see from that. Look at the dynamic nature of that solar atmosphere. But it was cloudy.
Oh my gosh! I was ready for the big like ta-da.
Yeah, good story.
Right.
Because much like today, there was predictions of cloud cover, and my husband and I decided that we were going to split up. And I was going to drive, we were going to maximize our opportunities for at least one of us to be able to see it. Right. So he went to the beach and I went up into the mountains. And for me, about 45 minutes before totality, the clouds parted. And so I was able to see the full solar eclipse from the mountains. And about 10 minutes before totality down on the beach, there was a very short cloud opening, and so my husband saw the first half of the totality on the beach. So we both got to see total solar eclipse just because of the nature of weather and the fact that it's dynamic. And so I'm going to think that maybe I'm a lucky charm.
And I peeked out while you were talking, Dr. Bishaki, a little bit earlier, and it's getting brighter, and I'm looking at the satellite back there, and we may just luck out here. There's still going to be that veil of high clouds over, but that'll be more of a transparent look. So, again, we're getting closer and closer and closer as we all get outside. I've got about 7 minutes and 40 seconds here, so I've got a couple more questions. This one will be for you, Dr. Ishak. would be, what is the interplay between this eclipse and right here at UTD?
Sure. This is the interplay between the eclipse and UTD. This is a wonderful event that actually brought all the community of UTD together, faculty, students, staff, and even the surrounding community. It brought us all together to participate in this event. And you saw what is happening outside. I think it's so fun. And so that's really a great thing. Additionally, a lot of people, a lot of friends calling me in the last 2 weeks about what's happening in UTD. And some of them brought their families here to campus. And so it really gave a great visibility to UTD. It connected us more with our community around us. So it's a wonderful thing that happened. So that's how I see the interplay. It's a really kind of created this or reinforced these connections with our community and also internally. It's a wonderful event.
Yeah, it's wonderful to bring us all together as a community here and across the path of totality as well.
Exactly.
So again, this is something that's, I'm super excited. I'm like, okay, we got 6 minutes and I'm going outside. I just want to I want to get on my social media. I want to get on my satellite visible. I wish I was 20 stories up right now. That's something really cool at some point if you get to travel somewhere. And let's say it's a timing issue, but if you know anybody that's a pilot or you have access to that, the best place to be, in my opinion, would be then after this one would be up in the air somewhere to watch the shadow coming from the southwest or whichever direction it's coming from. And speaking of space and getting up into the sky and things like that, this one for you, Dr. Stansberry, is what's the interplay between this eclipse and NASA? I mean, NASA equals space, right?
Yeah. Okay. In addition to the ongoing solar observations, we've got many missions that are specifically designed for solar observations, like the Solar Dynamics Orbiter, the Stereo spacecraft, those kinds of things. But NASA astronauts on the International Space Station also have an opportunity, along with weather satellites, to watch the solar eclipse. And it's a really unique vantage point, but again, it's all about location and whether or not the paths cross appropriately, because the International Space Station orbits the Earth about once every 90 minutes or so. Turns out that in addition to the GOES 16 and 18 weather satellites, the International Space Station will have a track that has 3 opportunities for seeing the eclipse. They'll be able to not just look up and see the eclipse, but they'll be able to look down and see the shadow on the Earth.
Wow.
For a partial eclipse over California and Idaho, and we were talking earlier about cloud cover, and even though it normally would have really bad opportunities for seeing the eclipse over the northeastern part of the U.S., Maine is actually clear today, and
Wow.
the International Space Station has an opportunity to view the shadow of the moon over Maine.
It's incredible. And we talked about that. At first, I haven't even really introduced myself to you yesterday when we had dinner, and it just came to mind because there's a site that you can go to. You can sign up for text messages if any of y'all want to see the International Space Station fly over. You'll get a text message, and you can do the thresholds if you want anything greater than 4-minute viewing, so you're not getting inundated all the time with 20-second viewings or right on the horizon. These are the ones that are shooting right overhead that you can actually see it come over. And all this just makes me really feel small. You know, I mean, just how tiny we really are and how big the planet we are is living off. And when I was little, I used to compare us to little fleas because the Earth can shake us off anytime it wants to, right? And so we need
Well,
to...
not with gravity.
Well, oh, just work with me here. So I forgot I'm a NASA scientist and a physicist right here. I do have a degree in meteorology, so I've controlled tornadoes, stuff like that. So it'd be nice. No, but yeah. So this is a really great opportunity for me and all of you out here. And we went outside and did a little cameo appearance right out into the, I believe it's called the Chess. The area, Chess Plaza. Does that sound right? And that's where a lot of you were out there, and we have a DJ out there. We have T-shirts, but hopefully if you haven't gotten one yet, looks like there's plenty of them out there. You can get your safety glasses, right? And also, I'm sure there's some type of beverages out there, some water and what have you. So I, myself, if you got here a little late, I'm meteorologist Dan Brunoff with KRLD Radio. And there's your little path there that starts coming up from the southwest out of Mexico through west sides of San Antonio and the hill country. Those areas down over here, well, let me go back, I'm sorry. These areas down here are going to have a lot more cloud cover, but there are some breaks. And again, I'll be out in the plaza here shortly, and I'll be broadcasting on the radio 4 times an hour and during totality. And so if you have any questions between my weather hits about weather or storm chasing, I did that for 40 years, or anything weather related, I'll be more than happy to answer. And you guys are going to be out there too. So if there's any questions, we normally would open this up to questions, but for time limitations, you can save those for outside. I'd be more than happy to answer those for you as well. So there's some of the times. Again, everything's pretty relative, 140 to 145 pretty much in our area. We're in the 3-minute something times threshold, about 3.5, 345 or something like that. So not too bad. And I do want to throw this up there. I was asked to let us know how we did. So I need to see all your phones in the air real quick. And you can fake it if you want, but please check it out, all right? And let us know. I'm kidding on that. Let us know how we did. I do want to thank Dr. Bushaki and also Dr. Stansberry. And also, she probably won't show. Come on out here for a minute. Come on, Stacy. She is truly, and all of her help, she's already gone. All of her helpers, Danny and other people, they have done a great job with setting this up with dinner and breakfast this morning and all the courtyard stuff and the plaza stuff that's going on. So I think I did pretty good. I'm a minute late. So get up, go on back outside, and we'll keep an eye on that cloud cover for you. And again, you can also, if you want, real quick, thank you. And that's it. So fade to black.